Good morning. Well, actually, for those of you not on the West Coast, good afternoon. My name is John Geldhof, and on behalf of the Society for Study of Human Development, I would like to welcome you to today's webinar. Today, Dr. Sara Johnson will present on the uses and potential misuses of latent profile analysis. This presentation is part of a larger webinar series sponsored by the Society for the Study of Human Development. All webinars in this series are archived on the SSHD website and are available free of charge to members of the Society. If you find today's presentation helpful, I encourage you to show your support for us by joining SSHD if you haven't already. SSHD is the only U.S.-based developmental science society that promotes a multidisciplinary lifespan approach to human development. Membership in the Society affords opportunities to interact with scholars from a wide range of disciplines, including psychology, sociology, family studies, gerontology, biology, economics, cultural studies, and history. As an organization, we move beyond the more common age-separated scholarly societies and take an integrative approach to lifespan development. The Society is committed to engaging in rich discussions of developmental theory, strives to bring together diverse methodological approaches, and has been a leader in promoting scholarship that addresses the need for innovative methodologies in the study of human development. SSHD is also unique in that the Society is firmly committed to developing the next generation of developmental scientists. We provide opportunities for junior scientists to gain theoretical, methodological, and applied knowledge, as well as enhance their professional networks. In addition to receiving access to archived webinars, membership in the Society provides access to the Society's flagship journal, Research in Human Development. Regular membership is $75 and student membership is $40 annually. For more information and to join, please visit the Society website at www.ssshdonline.org. For today's talk, we have muted everyone's microphones in order to minimize background noise. If you have any questions during the presentation, please submit them to me using the chat box, and I will forward them on to our presenter. Dr. Johnson has agreed to take brief clarification questions during her presentation, but has asked me to hold substantive questions until the end of the presentation. We also hope to have a few minutes at the end of the webinar to field more general questions. So without further delay, I'd like to thank Dr. Johnson for presenting and hand the webinar over to her.
Thanks, John. Welcome, everybody. Good afternoon for folks on, the East Coast, and good morning to John and other folks on the West Coast. I'm happy to be here today, actually speaking to you from my home, since Tufts is not holding classes today. We have about 3 feet of snow on the ground. My name is Sara Johnson. I'm a research assistant professor at the Elliott Pearson Department of Child Study and Human Development at Tufts University. And I'm very excited to talk with you today about the uses and potential misuses of latent profile analyses. The content of this presentation is based on my experiences as an analyst. Oh, John says you can't see my slides. Okay. My experience as an analyst who uses LPA. Let's see. Apologies for the delay here, folks, while we make sure that the slides are viewable. Aha. There we go. Okay, so I hope everybody can see my slides now. As I said, this presentation is based on my experience as an analyst who uses LPA. I'll actually tell you about a few of the analyses I've done using the LPA approach. And as a bit of, this calls me out as a total nerd, but as a bit of a LPA specifically and mixture modeling in general aficionado, if you will, and also as a reviewer of journal articles using latent profile analyses. So as soon as you submit an article to a journal that uses an LPA and it seems like you might know a little bit about what you're doing, you find that you start to get invitations to review other articles that get submitted to those journals using those methods. So I would estimate I've reviewed about 8 articles in the last year that use LPA as a technique. So I have quite a few thoughts about the strengths and potential pitfalls of LPA that I've seen in those articles that I've reviewed as well. So the focus of this webinar today is not on the nuts and bolts of how to conduct a latent profile analysis. That would take much longer than the time that we have allotted for this webinar. Rather, today I will give you an overview or an introduction conceptually of what LPA is, how it can be used, the different advantages, and the really kind of cool ways that we can use LPA to answer some of our research questions, and the potential dangers and misuses of latent profile analyses, particularly as they relate to analysis, the actual analysis process, and then also quite a few problems that I see sometimes in terms of interpreting latent profile analyses results. And at the end of the presentation, I have provided lots of resources for further study in case you decide, in case today is a rousing success and I convince you that you might want to do an LPA, that it might be able to help you with your analyses that you do. So I'll have some resources for you at the end in terms of how you can learn on a more step-by-step basis about how to conduct a latent profile analysis. So first, before I start talking about all of the wonders of LPA, I want to go over a quick, unfortunately, woefully under-detailed description of what LPA actually is. So thinking about viewing LPA from airplane height, a flyover, if you will, rather than driving on the road conducting an LPA. And as I said, I've provided lots of resources for on-the-road type things at the end of this presentation from people who are extremely well-versed in the nuts and bolts of the LPA technique. So what I will talk about now is a conceptual overview of the latent profile analysis model. So the first and most important thing to know about latent profile analyses is that they are a mixture modeling technique. Today I will talk a lot about latent profile analyses specifically, but quite a bit of what I will say is also generalizes to mixture modeling in general. So I think it's important to understand the guiding framework behind a latent profile analysis, which is the mixture modeling framework. So I think it's easiest to understand mixture modeling from the perspective about why would we want to conduct one. And I think that helps with the understanding of what the point of a latent profile analysis or another type of mixture model is. So we are often interested in subgroups, and when I say we here, I mean broadly developmental scientists and people who conduct research related to child development, human development, family studies, and all of the associated disciplines. So we are often interested in subgroups because our theories tell us that all people are not alike and that our statistical results will not necessarily apply to all people equally. So variable-centered analyses, which focus on average relations between variables across all people in your data set, your sort of regular regression-based analyses, they may not represent everyone in a sample equally well. So we often conduct subgroup analyses, even with our variable-centered analyses. So for example, lots of folks conduct separate analyses by gender groups or by year in school or based on a particular program that someone might be attending, so on and so forth. We often try and figure out what are the subgroups in our data, but we're usually limited to subgroups that are based on variables that we have directly asked people about. So we can ask people, what is your grade in school? The challenge with that is that our theoretical models tell us that we probably also have subgroups in our data that are based on the way people answer questions. And we can't ask them about that directly. We have to infer whether those subgroups are there based on the questions that we've asked people. And that is where mixture models come to the rescue, so to speak, because the aim of mixture models in general, and again, a latent profile analysis is just a specific type of a mixture model, is to classify individuals into distinct categories based on their individual response patterns. And the goal of this is to make groupings so that people within a group are more similar to each other than they are to individuals in other groups. So in other words, we're trying to maximize within group similarity and maximize between group dissimilarity. And so mixture models can help us figure out, are there groups of response patterns in our data? If there are, how many different response patterns or groups can we find? And if we find them, how can we characterize these groups? What are these groups like? So these are the aims of mixture models in general and latent profile analyses in particular. Now, mixture modeling is really a family of techniques that I have mentioned. Latent profile analysis is really just one of them. And there are cross-sectional mixture modeling techniques. Some of the ones that you may have heard of include latent class analysis, latent profile analysis, which is also known as latent class cluster analysis, factor mixture modeling, and many more. These are techniques that are often applied to cross-sectional data. And then there are different types of longitudinal mixture modeling, such as latent transition analysis, latent class growth analysis, growth mixture modeling, and more. There are many, many different types of mixture modeling techniques. And the main differences between them are on what the groups are based on. So in a latent class analysis, for example, the groupings are based on people's responses to categorical items, survey items that we have asked people. In a latent profile analysis, those items are often continuous. So you will often hear people use the terms latent class analysis and latent profile analysis somewhat interchangeably, because really the aims of those analyses are quite similar. It's often simply the items that are used within the analysis that are slightly different, with latent class analysis being categorical items and latent profile analysis being continuous items. But again, it can be a small distinction, and so those terminology are often used interchangeably. So mixture models are a latent variable technique. So I find it helpful to think of a latent variable as a variable that is not directly observed. So again, a mixture in our data, groups in our data, are something that we can't see right away by looking at it. But instead, latent variables are inferred through a mathematical model from other variables that we actually do ask people. And so we're all familiar probably with quite a few different types of latent variable models that many analysts use on a regular basis. And so I like to segue, I guess, into talking about latent profile analysis by starting with a different type of latent variable technique that we're all more familiar with, which is confirmatory factor analysis. So I'll start off with talking a little bit about the confirmatory factor analysis model, and then show you how the latent profile analysis model is just a slight difference based on that model. And to make that discussion just a little bit more concrete, I'll use an example of an analysis that I conducted with some colleagues at the Institute for Applied Research in Youth Development last summer. That has recently come out in the International Journal of Developmental Science, called Profiles of Civic Actions Across Educational Transitions, Stability and Change. So in this study, we were interested in looking at civic participation across the transition to adulthood. For a variety of reasons, civic engagement is one of my substantive research areas, and in that way I often employ mixture models and latent profile models specifically, and we were interested in identifying patterns of civic engagement among college students. So, okay. So as I mentioned, to start off, we will look at what would this analysis have looked like if we wanted to do a confirmatory factor analysis of these data. So quite a bit of civic participation research has to do with how often are people participating in different types of civic activities. So we asked people how often they had volunteered to start a club, to organize people around a cause, to volunteer in their community, to act as a mentor, and to be a leader in a group or organization. So these are the actual items that we asked. And if we were to do a confirmatory factor analysis, we would be trying to figure out from these items how much of this latent variable of civic participation do we have. So as I said earlier, a latent variable is a variable that we infer based on a mathematical model from items that we've asked people. So in the case of confirmatory factor analysis, the mathematical model that we use gives us factor loadings. So this model that I put up here on the screen is probably pretty familiar to a lot of folks who are familiar with confirmatory factor analysis or the broader framework of structural equation modeling. And the factor loadings here tell us how much each item is related to this thing that we can't observe called civic participation. So that was a confirmatory factor analysis in which we have a continuous latent variable that represents how much civic participation people have. So I want you to keep thinking about this idea of a latent variable, of how much civic participation people have, but instead of thinking about how much, think about a latent variable that represents what kind of civic participation. So we're still talking about taking these items that we asked people and coming up with a latent variable of civic participation. But in this case, we want to use these items to look for differences in type of civic participation. So instead of factor loadings, the mathematical model that we're going to use will then give us means. So it will show us, do the means of the various items differ according to the type of civic participation that types of civic participation that we identify in our data. And what this might look like, what it looked like for this particular analysis, can be represented through pictures such as this one. And I'm a visual person. I know a lot of folks are, and appreciate viewing results of analyses such as latent profile analyses through charts or graphical descriptions. And so these are the profiles that we identified in the particular study that I'm using as an example. With these 5 indicators, we identified 4 profiles within our data, primarily differentiated by overall amount of participation, but also how much the profiles were characterized by participation in activities that required a lot of initiative. So you can see the organizers, for example, they weren't really doing a lot with clubs, but they were doing a lot with organizing, people around a cause, as were the high involvement folks who were also starting clubs. And you can see that the low initiative profile was characterized by moderate involvement in volunteering, mentoring, and a little bit of leadership, but less involvement in organizing people around a cause or starting a club. So these are the types of results that you can see from a latent profile analysis, where we're really identifying what is the type of civic engagement here rather than how much. So you can see that the high involvement folks, for example, and the organizers have similar levels of certain variables, but less similar levels of other variables. So they are distinguished based on their pattern of involvement. So this is just one example of a latent profile analysis. I'll show you a couple more examples in a moment, but I want to tell you a little bit now about how the latent profile analysis process works. So if at this point you think, hey, latent profile analysis might be an interesting way to model these data about X that I have, and that it's consistent with what you would expect based on your theoretical framework. So I have, at this point, perhaps convinced you that you might want to try to do your very own latent profile analysis. So how would that analysis process go? It starts with you, and there's a large role in the latent profile analysis for the analyst. One of the things that I think distinguishes mixture modeling from other types of analysis, although this is certainly true for other types as well, is that there are lots of judgment calls involved in the latent profile analysis process. I'm going to tell you about quite a few of them, but it's important to know that this is a field of analyses, or a type of analyses, in which there are some gray areas, and it's important for analysts using the technique to really be transparent about the process that they're making. So the analysis process for latent profile analysis actually is somewhat similar, I think, to an exploratory factor analysis process, where you have to specify different numbers of factors and then look at the solution. So there are some similarities there. But again, it starts with you, and you have to specify what you want your profiles to look like. So the first thing you specify is the number of profiles, and it's common to test models with various numbers of profiles, starting with 2 up to a few past whatever your theoretical model guides you to thinking is going to be the most appropriate number of profiles. And your theoretical framework may have more or less strong suggestions about that. And so sometimes the upper number of profiles can be dictated more in an exploratory way by when the models stop running. So in addition to specifying the number of profiles, you also have to decide what the variances and covariances are going to look like within the profiles. So if we look back at this diagram of the latent profile results that I showed you earlier, you have to decide whether you want the class variable or the profile variable to be completely responsible for the correlations between items, or whether you want there to be a residual association there. So if we go back and look at this diagram, it's somewhat similar to making a decision in confirmatory factor analysis about whether you want there to be correlated errors between items. So do we want the association between how many times you've started a club and how many times you've organized people around a cause to be totally because your response is characterized by profile 1? Or do we think there might be a little bit of a residual association left over there? So if we say that things are not correlated within profiles, that is an assumption, that's a term that you'll run into called conditional or local independence. And that's a decision that you as an analyst have to make, and people vary in their opinions about what you should do there. And if we have time at the end of this webinar, I would be happy to discuss what I see as the relative advantages and disadvantages of various specifications here. You also have to decide what the distribution of your variables is within your profiles. So in each profile, you'll get obviously a mean level of involvement, for example, for each item, but you also have to say whether you want your variables to be normally distributed. So it used to be until last summer, I believe, that a latent profile model would make the assumption by default, at least in M+, that everything was normally distributed within profiles. That is no longer the case. You can actually relax that assumption if you have variables that tend to be not quite categorical, but not really nicely normally distributed either. So that is an option as well. That's pretty recent. And I'll say here, and probably again later, it sounds, again, calling out my nerdiness a little bit, but this mixture modeling and how to specify models and how to decide on the number of classes, these are veritable hotbeds of methodological activity. You'll see at the end I have a bunch of papers that have just come out in the Structural Equation Modeling Journal. These are areas that are active in terms of methodologists trying to figure out what's the best way to go about things. So if you feel that you're interested in doing latent profile analyses, it's something to either try to keep up with yourself, keep track of what's coming out in those journals, or make friends with someone who likes reading those kinds of articles and can help you decipher the sometimes not terribly understandable articles that come out in journals such as SEM and Psych Methods. But just to know that there are continuous developments pretty much coming out in these methods that are important to keep track of. Okay, so you specify the number and the nature of profiles. You make some decisions. The computer, as best as it can, will run a model with the number of profiles you specified. I do want to say on behalf of software programs that successful computation of a model does not imply endorsement on the computer's part of that number of profiles. So simply because the computer was able to find a solution for 3 profiles or 4 profiles doesn't necessarily mean that that's a good model or a good solution, just as it isn't for a confirmatory factor analysis or any other type of analysis that you would do. So it's your job to look at the output that the computer gives you and to investigate how does this solution look? Does 3 profiles, does this seem to be providing a good fit to the data, or how about 4 profiles? And you have to go back and forth, like I said, similar to the EFA process, and decide what you think, which number of profiles provides the best representation of your data. So how are you supposed to do that? Well, as I mentioned, this is a very contentious, might not be the right word, but there's a lot of activity going on in terms of how do we choose the number of profiles. So the formal name for this process is class enumeration, which means deciding how many profiles or classes provide a good fit to your data. And so there are statistical indices that you can use, information criteria, likelihood ratio tests. Again, I'm happy to talk about these more specifically if we have time at the end of the webinar, but I've also provided at the end several good resources from people who do who do research on these indices themselves, so methodological research that can give you more information about how to conduct this process. And there's also substantive considerations such as consistency with theoretical expectations and interpretability. And there's also the classification accuracy of your model to take into consideration, especially if you want to conduct further analyses with the profiles, as I'll explain later. So I would give about equal consideration, about 50-50 consideration to your statistical indices and your substantive considerations. I think that it's very important not to be a slave to either one. So it's important not to abandon theoretical expectations simply because the statistical indices show that 4 profiles provides a minuscule improvement in model fit over 3 or something like that. But it's also important not to blindly ignore statistical indices just to pick which number of profiles matches with your theory. So I think it's important to consider statistical indices and substantive considerations about equally. Okay, So I hope by now that I have convinced you that LPA is doable and not all that different from other types of latent variable models that we use on a regular basis, although it does have its particular idiosyncrasies and things to keep in mind. So I'll tell you a little bit more now about the advantages and what I think are potentially some cool things that we can do with latent profile analyses. So to me, the biggest reason, the reason why I got into mixture modeling when I was a graduate student is that the ideas behind latent profile analyses and other types of mixture models are very much consistent with many theoretical perspectives and frameworks that we love within developmental science. We are often interested in how people are like some other people, not necessarily everybody, and we want to be able to target or make use of programs and policies or interventions in a more nuanced way based on whether there are particular subgroups in our population. And I think we know that in a lot of cases our variable-centered analyses may not be the best representation of our theoretical ideas. They often are, but they sometimes are not. And so theoretical models that we use that conceptualize individual differences at the latent level, at least, as differences in type or kind, right? We often think that people differ not just in how much of something they have, but what they have or what kind they have. Those types of theoretical frameworks lend themselves very, very nicely to a latent profile analysis or some other type of mixture modeling approach. And along with that, latent profile analysis is a flexible and powerful way that we can address those aspects of our theoretical frameworks about how people are different in terms of the kind or type of something that they have. And there's a lot of ways that we can use latent profile analyses to find out these differences in kind or type. And in terms of LPA specifically, one of the most common questions that I get is, okay, Sarah, this kind of sounds like a cluster analysis that you're talking about, so can you please tell me about how LPA is different or what advantages LPA might provide over a cluster analysis? So I wanted to touch on that briefly. So some advantages of LPA. Now I don't want to make this sound like I'm anti-cluster analysis, because I'm certainly not. But I do have, as I mentioned, a soft spot in my heart for LPA, but that's for a reason. LPA has earned its way into my heart for these reasons, that LPA can accommodate both continuous and categorical variables. That's sometimes referred to as a mixed mode LPA or a mixed mode LCA, just to make things confusing. The variables can be on different scale. Often we ask people some questions on a 3-point scale, some questions on a 5-point scale, and LPA can accommodate those right off the bat. You don't even have to do anything. But the biggest advantage, I think, of a latent profile model and all mixture models is that they are what's called model-based. So that means that we are imposing a probabilistic model on our data and talking about, if there are profiles that look like this, what's the various probabilities of people responding in certain ways. And the advantage of LPA being a model-based technique as opposed to cluster analysis, which is based more descriptively on specific distances between data points, is that you get a much larger array of fit statistics in a latent profile analysis that can help you decide more easily sometimes how many profiles are the best representation of your data. It's still not always an easy process, but you can get a little more information from your fit statistics about that. And you also get LPA incorporating classification uncertainty. And that means that LPA and mixture models in general treat people's mixture membership, or whichever profile or group they are members of, as uncertain. And you can get an indication from the model about just how uncertain it is. I mentioned classification accuracy before in terms of how, based on the number of profiles, how confident is the model about which people's response patterns go into which category. And that can be very helpful as well in helping you determine how many profiles best represent your data. And classification accuracy also, in my mind, is a more accurate representation of reality and about what these types of grouping type models really give us, that we can be pretty sure about what response pattern characterizes, what group characterizes people's response patterns, but not completely sure. It's not a said and done, just totally decided thing as it is in a technique like cluster analysis. So to show you other advantages of latent profile analyses have to do with the particular types of extensions or the ways that we can continue on with LPA. It doesn't have to end just with the identification of profiles. If you're left wanting more and you're thinking, well, that's nice, profiles, but those profiles might mean something. They have implications for how we might do things, and that absolutely can be true. So we can look at predictors of profile membership. So for example, are boys or girls more likely to be classified into certain profiles, or based on year in school, or program attendance, geographic residence, basically any kind of variable that you think might be related to profile membership, you can look at it. You can also have profile membership predict a distal or a later outcome. And there are different ways of doing that in terms of are different profiles of school engagement related to later dropout or certain things like that, or different profiles of civic engagement. Are they predictive of later voting behavior? There's infinite possibilities in terms of how to incorporate distal outcomes into a profile analysis model. And in case those are not enough for you, you can also look at whether profile membership functions as a moderator of relations between other variables, just like other types of moderation analyses that we would do. For example, if you thought relations between some predictor and outcome variables were different for boys or girls, the extension of that analysis is to see whether those relations are different based on profile membership. And I'll give you an example of that in an analysis that I did in just a few slides. I want to say here, though, that doing these extensions of LPA analysis, because LPA incorporates classification uncertainty, it makes doing these types of models a little bit more complicated. And so this is another area. You can see all of the areas where people are just doing all kinds of methodological work about LPA. So there's 4 or 5 papers, I think, that have come out just in the last year about different methods that you can use, especially as it relates to distal outcomes. So there are several different analysis choices depending on, do you want to predict a continuous variable or a categorical variable, or what do you want to do? There's different methods of doing it, and they all have their advantages and disadvantages, which, again, I'm happy to talk about if we have time at the end of the webinar. But I do just want to emphasize the point here that these types of analyses can be very illuminating, and they're really cool, but they must be done very carefully. And we'll talk about that again in a moment. So to give you an example of another latent profile analysis that I was involved with, it's a paper that came out last year with some other folks at the IARD, profiles of problematic behaviors across adolescence, and we were interested in how those profiles were related to indicators of positive youth development. And the reason why we chose the LPA approach was that our theoretical perspective led us to assume that all risk behaviors are not created equal. They're demonstrated in different ways by different youth, and they likely have different consequences for different youth, especially depending on the presence or absence of other types of risk factors. So we thought that it was really about the pattern of risk behaviors, the constellation of how they all fit together in different groups that was the most important. And we identified 6 profiles of risk behaviors using data from the 4-H study of positive youth development. And if you're interested, I should have mentioned this earlier, but if you're interested in this paper, the paper that I mentioned earlier about civic participation, or the paper about mentoring that I'll talk about in just a moment, please do email me, and I'd be happy to send you those papers. You can also find them using the citations at the beginning. And we also looked with these 6 profiles, and we found differential associations or differences between profiles and the 5 C's of PYD. And we looked at that across quite a few waves of the 4-H study. And so this last bullet here is the type of extension of analysis that I was talking about. Another paper that I worked on last year, also using data from the 4-H study of positive youth development, was about important non-parental adults and PYD across mid to late adolescence and the moderating effect of parenting profiles. So in this paper, we were interested in the integrative or simultaneous effects of resources both in and out of families. And so we identified profiles of youth, how youth perceived their parents to be parenting them, so how they would describe their parents' parenting. And we looked also at whether youth said that they had an important non-parental adult or a mentor in their lives. And one of the things we found was that youth who perceived more positive parenting from their parents were more likely to report having an important non-parental adult in a sort of rich get richer situation. That's not an uncommon finding in the mentoring literature. But an important finding of this study is that we actually looked at how parenting profiles moderated the relation between having a non-parental adult and the 5 C's. And what we found was that although, as I mentioned, youth who had more positive parental relationships were more likely to say they had an important non-parental adult, the relation between non-parental adult presence and the 5 C's was stronger for youth who had less positive parenting. So there appeared to be some sort of a compensation type relationship happening there, which was a finding that our LPA-based moderation analyses enabled us to find. Okay, so now I hope that you're really convinced that LPA could potentially be useful in some type of way for the analyses that you might conduct. And so before this webinar ends and I send you out into the world to conduct your own LPAs, there are a few potential misuses or caveats of LPA analyses that I want to bring to your attention. So one of the, when I'm reading papers that I get to review that use LPA, one of the biggest omissions is the theoretical rationale for why a mixture model, why a latent profile analysis. And sometimes it seems pretty obvious that the authors may have tried some other variable-based analyses or maybe they used a scale score of civic participation or something. By the way, that's not what we did. And couldn't get any interesting results. And so they threw their variables into an LPA. Sometimes they get interesting things, but there's a lack of rationale for it in their literature review. So a big caution is to make sure that you have a theory predicated reason for conducting an LPA or some type of mixture model. I know that after attending this webinar, of course, everyone is going to be chomping at the bit for conducting an LPA analysis. Everyone's going to want to do it tomorrow because it's so cool. But make sure that you have a reason and that your theoretical framework is really pushing you towards wanting to look at these different profiles, and make sure that that's really clear when you're writing up your results. It's also good to have a theoretical rationale because it makes it a lot easier to interpret your results. If you don't know what you're looking for, it is hard to decide about whether what you found is interesting or not. Another challenge that I often see is a lack of transparency and, in some cases, possibly cherry picking of the class enumeration process. So I often see only a few fit indices reported, or a general sentence about fit indices were equivocal, and then just a relation on theory or something like that. And so it is important, as in any type of modeling, and this can happen in other methods too, to be transparent about how you selected the number of profiles. It is often the case that your statistical indices will be equivocal. They might not point you in a specific direction, in which case you have to, rely on your brain to figure it out, and that's okay. It's just very important to be really upfront and report all of the different fit indices that you looked at, even the ones that didn't necessarily support the solution that you picked. That's very important. The other challenge that I've often seen is that sometimes you will get a result that looks somewhat like this, which is where the profiles really appear to only be differences in degree, where there's really a difference of how much that is being represented by these items rather than a difference in kind. And so this type of a result could just as easily and perhaps better be represented through a confirmatory factor analysis with a continuous latent variable. So I think it's important to be honest about whether a latent profile is really providing the best fit to your data. I've encountered a few papers lately in doing their group comparisons. They have moved right into thinking that the number and nature of the profiles is the same for each group, and they have not first tested whether that is true. So it's sort of like, if you're familiar with the CFA process of invariance testing, it's like skipping the configural invariance phase of invariance testing. So first you have to check and see whether the number of factors is the same and the pattern of loadings is the same. And the same is true for a latent profile analysis. So my hearty recommendation is that you investigate what does this LPA look like if we do it separately by group. And you may find something very similar. You may find something very different. But in any case, you're giving the data their full chance to show you what they've got, rather than assuming that things are going to be the same for each group. As I mentioned before, doing follow-up analyses can be a little tricky. I find by default most people just want to save, well, what other profile are you most likely to be in? Because software programs will save that for you and use that as an observed variable in further analyses. And that is by far the easiest way to do it. I'm not going to lie about that. The more recent and more recently available approaches are, in some cases, more difficult to implement. But I would urge you to carefully consider the options, because in some cases, simply using profile membership as an observed variable can be very biased. And there are lots of folks who have done really excellent simulation work that have shown all the many ways in which doing that type of analysis can be biased. In some cases, if your model is very sure about who goes in what profile, then these analyses can be less biased, but that's not often the case. So I would urge you, as I said before, to carefully consider your available and ever-expanding options for conducting follow-up analyses with profiles. At least figure out what you're getting yourself into, and consult somebody who has some familiarity with these techniques. A final note on potential misuses of latent profile analysis is that your profiles are dependent on and only as good as the items that you use to model them. So, and this actually relates to some of the interpretive issues that I'll touch on in a moment. Your profiles are based on your particular items. So thinking back to the civic engagement profiles that I showed you earlier in this webinar, those were profiles of civic engagement based on those particular 5 items. And it is definitely the case that had we had different items, things might have turned out a little bit differently. It's one of the reasons to use multiple samples, use multiple different types of items to see what happens, and to make sure that the items that you're choosing are based on what your theoretical framework or perspective are telling you are the most important items to include. So remember that your LPA, as with any model really, is dependent on and only as good as the items that you use to model them. So a few potential misuses related to interpretation, and these are all variations on a theme, is that I will be the first to say that naming the profiles can be really fun, but there is also the temptation to get a little bit too cutesy, perhaps in naming your profiles, and by so doing, to assume that people are the profiles and that they are what we have named them to be, to have a bit of a nominalistic fallacy going on here. Just because we name something doesn't mean they are what we are calling them, or that we really understand them fully. So I would urge people to use common sense and to be as descriptive as possible when naming your profiles, and to use cautious language when you're making statements about profile characteristics and people, people in profiles. Related critique is that simply because the model showed that a profile solution was an okay fit, and even if it was the easiest process in the world, that doesn't necessarily mean that the profiles represent truth or that they are real. Again, they are often sample dependent, item dependent, and specification dependent, depending on how you specify your model. And so using a little bit of caution in how you're describing your latent profile analyses is very important. And that remembering that they're a model, they're a way to represent your data. So with mixture modeling, as with other modeling, but I think this is particularly true, I think back to a quote from Tukey, which is, the combination of some data and an aching desire for an answer does not ensure that a reasonable answer can be extracted from a given body of data. So just because you want a mixture model to happen doesn't always mean that it's going to happen. It could be due to a variety of factors, mismatch between your items and your theoretical model, or particular misbehaving characteristics of your data, many different reasons, but sometimes it just does not happen. If, however, despite those caveats, you have decided that you would like to do an LPA, I've provided here a few resources for folks. different software options for conducting latent profile analyses. I do most of them in M+, which has many different options for latent profile analyses, as well as other types of mixture models. SAS has many options also. The excellent folks at the Methodology Center at Penn State put out wonderful macros to help you do various LPA and LCA analyses in SAS, and their website, again, the Methodology Center at Penn State, is a great resource about various types of mixture models. Latent Gold, the statistical innovations picture here, also can conduct some mixture model analyses, as can the GLAM procedure, GLLAMM, I believe it is, in Stata. So there are ever-expanding options for conducting mixture models, although unfortunately you will notice that SPSS is not on here. So a book that I found extremely helpful, although it's about latent class analysis rather than latent profile analysis, is this book by Linda Collins and Stephanie Lanza, again out of the Methodology Center at Penn State. They have a really great description of various aspects of the latent class approach and technique, and also how to extend that longitudinally to a latent transition analysis. I would recommend going to a week-long workshop if you can. I did a little digging around online, and I found that the STATS camp, which is now run out of Texas Tech, will be holding one this summer, and the instructor for that is Catherine Mason, and I've had the pleasure of meeting Dr. Mason, who's now working out of Georgia State, and she is really great at explaining various components of mixture modeling, as well as being a pretty great person. So I would highly recommend taking a workshop from her if you can. Just FYI, no one paid me to say that. It's just my personal opinion. And then I have some more advanced readings for you. I'm not entirely sure if this PowerPoint will be available along with the webinar, but I can certainly make sure that this list of recommended readings is available for folks, because there's quite a few things on here that I can talk specifically about if we have time. And the other resource I will point you to is the M+ website, which is statmodel.com, and they have different web notes about how to use techniques in M+, articles, and example syntax for M+, which is very helpful. I think that's all I have for today. I noticed it is 2:58, so we have a few minutes to take some questions if there are any. And thank you very much for this opportunity. I
was going to say, if anybody has questions, please submit them through the chat window on your GoToWebinar screen. There should be a little plus sign next to the chat you can click on, and then you can just type your questions in there.
And if you are just so overwhelmed with the wonders of LPA right now and you don't think of your question until tonight when you're trying to fall asleep, I'm happy to answer questions later over email also. My email is s.johnson@tufts.edu. I'd be happy to take questions at any point later also.
So Sarah, we did have one question about handouts. Do you know, are you going to be able to make handouts available to people?
The PowerPoint slides?
Yeah.
Oh, sure. Yeah, absolutely. I'm very happy to share those. And that would also solve the problem of where to have the reading list also.
Right. Well, I don't see anybody posting questions, so I'm going to ask a question of my own. Can you, of course I'm going to.
I knew you would.
A little bit about the non-normal distributions. This has been a major issue in the LPA literature.
Yes.
Why would we consider non-normal distributions?
Why would we consider them?
Yeah, why would we want to look for classes using non-normal distributions instead of normal distributions?
Well, because often they're not there. I mean, the assumption that things are normally distributed within classes or within profiles, I think, is not super realistic, and it expands the possibilities of variables that we can include in our latent profile analyses. You know, some of the civic participation variables, for example, are not necessarily normally distributed. They have some skew and kurtosis problems. Although I do have to say that I've not spent a ton of time on the new utility for non-normal distributions, but I have. It does take a lot. It's much more computationally intensive. It takes a lot longer to run, and it didn't necessarily go as smoothly as I was hoping. It didn't magically solve all of my LPA problems.
Mm-hmm.
So I need to do some more playing around with that. I'm hoping to do that with a few analyses that I have coming up. But it is another illustration of how the options for LPA are rapidly expanding and can accommodate a wide variety of data situations.
Great, thanks. So there's no more questions, so I'd like to thank everyone for attending today and remind you that the webinar will be archived. What was that?
Thanks, everybody.
So yeah, so for the archived version of today's talk, you can go to the SSHD website if you are a member. If you're not, you can also go to the website to join. It's again www.sshdonline.org. And thank you, everybody.